Hello, everybody. Earthquakes, pH, and sound intensity. So let's go over um, three different applications of logarithmic functions, physical phenomena that are measured on a logarithmic scale. We started our unit talking about earthquake intensity. We'll end it here with earthquake intensity. Earthquakes are physical phenomena that have a large range of values and therefore are measured on a logarithmic scale. Here's the formula. M is the magnitude. That's the number you frequently hear on the news when there's an earthquake somewhere in the world. It's measured on the Richter scale. A divided by A naught. This is the intensity ratio. After comparing the earthquake intensity as measured on a seismograph, so like this, okay, to the intensity of 1 micron. It's invented by Charles Richter. Each increase of 1 unit on the scale, so 1 unit on the scale, represents a tenfold increase of actual intensity. So a magnitude 5, so if I look at my scale, folks, a magnitude 5, down here somewhere, magnitude 5, earthquake is 10 times more intense than a magnitude 4, 10 times, 100 times more intense than magnitude 3, and 1,000 times more intense than magnitude 2, and so on. Okay? Determine the magnitude of an earthquake with an intensity of 10 to the 7.3 microns. So I need to set up my equation. M, magnitude equals log of A over A naught. Okay, and I'm plugging my values in. And I turn it into exponential form. Right? Oops. No, sorry. Let me simplify this, and then we'll talk about it. So 10 to the 7.3. Hey, you can evaluate this on a calculator, or let's just think about it. 10 to what? 10 to the m. 10 to the m equals 10 to the 7.3. So m must equal 7.3. Okay, you don't need a calculator to do this one. Okay, number 2, determine the intensity of the earthquake with a magnitude of 3.4. Same equation. What do we need? What do we have? 3.4 magnitude. And we want to know the intensity. Let me just bring it over here. This A over A naught value, I know there's two variables, but A naught is that reference magnitude, the one you can barely detect, right? So what we're looking for is the comparison of the intensity A over A naught. So the intensity of the earthquake as measured, remember, on a seismograph, compared to the reference intensity. So A over A naught is what we're solving for. So remember, it's base 10, so that's 10 to the 3.4 equals A over A naught. And what does that equal? That equals 2,512 microns. Okay? Comparing two earthquake intensities. Let's develop the formula. If we're comparing two intensities, folks, magnitude 1 minus magnitude 2, we're going to modify the equation appropriately. So that's log of intensity 1 divided by the reference intensity minus log of intensity 2 divided by the reference intensity. let's use laws of logs to rearrange this. So if I'm subtracting two logarithmic terms, that I will divide the two arguments. Okay, let's bring it over here. Okay, we can see the two a0 terms divide out to 1. So we're left with this, folks. This is our comparison formula. This is how we derive it. Magnitude, first magnitude divided by the second magnitude equals the log of the ratio of magnitude 1, the intensity of earthquake 1 divided by intensity of earthquake 2. So this is your comparison equation. Okay, example 3. In Chile, 1960, let's call this A1. Had an earthquake that measured 9.5 on the Richter scale. In 2005, it had an earthquake that measured 7.5 on the Richter scale. So let's call this A2. So A1. Oops. Sorry, folks. I'm gonna go. Let's go blue here. A1, and then let's go A2. To the nearest whole number, how many times more intense was the 1960 earthquake? So use my comparison formula. 9.5 minus 7.5 equals log of A1 over A2. Okay. Right away, we can see that this is 100 times more intense, right? Because what's my result here? 2 equals log of A1 divided by A2. Remember the Richter scale? Every unit increase. So if I go from 7.5 to, oh, there's the Chile one, 9.5. I'm going 1 unit, 2 units. Sorry, 1 unit and 1 unit. That's 2 units. This is 10x increase or tenfold. This is another 10x. So 2 units means 100 time increase. Okay, 2 units. 2 units. This is 2 units. But let's do the calculation. Remember, this is base 10. So we say this is 10 squared equals A1 over A2 when we convert it to exponential form. So 100 equals the ratio of the intensity of earthquake 1 to intensity of earthquake 2. Let's cross multiply. If we do this, A1 intensity of earthquake 1 equals 100 times the earthquake intensity of earthquake 2. So 1960 earthquake was 100 times more intense. Oops, spelling. Intense than 2005 earthquake. Okay, example 4. A major earthquake of magnitude 7.5 is 375 times more intense than a second minor earthquake. So I shall call this A1, second minor earthquake A2. To the nearest whole number, determine the magnitude of the minor earthquake. Okay, so let's write our equation. And let's ask ourselves, what do we need? What do I have? Okay, the first magnitude, that is 7.5 minus second magnitude, that's what I'm looking for. A2, that corresponds to M2, right? A1, M1, okay? So log of, okay, what's A1 over A2? Well, it says the major earthquake magnitude is 375 times more intense than the second minor earthquake. That's a comparison, folks. So that means A1 over A2 equals 375 if I'm comparing the first earthquake intensity to the second one. So 375. So rearranging, so let's do this. Bring this over, that's 7.5 minus log of 375, and that equals earthquake intensity 2. Okay, and then this one you'll need a calculator, and just give me a sec here. So 7.5 divided by log of 370. Sorry, folks, just give me a second. 375. I get 4.925968 equals M2. Let's round that to the nearest tenth. So round to tenth. Okay, so that's going to be 5.0. So the magnitude, so the second minor earthquake is a magnitude 5 on the Richter scale. So second minor earthquake was magnitude 5 on the Charles Richter scale. Okay? All right.